So this video is going to cover angles of elevation and depression, okay? We're going to use these angles to help us solve problems in the real world that require trigonometry, okay? So anytime you've got a situation where one object is elevated above another or is a little lower than the other, it creates a right triangle with what we call the horizontal. Now, a lot of times this horizontal is going to be the ground, but sometimes the horizontal can be an imaginary line from one object horizontally out from that object, okay? So we've got two terms here. Angle of elevation is going to be from the horizontal line up to this ray that's forming the angle, okay? So the angle of elevation always goes from the horizontal. So if the horizontal then up to create this angle, that's why it's called the angle of elevation, okay? If we go from the horizontal down, okay, in this case the individual is looking down at this object underneath the sea, then we're going to have an angle of depression, okay? So if we're looking down, it's an angle of depression. If we're looking up, it's an angle of elevation, okay? The main thing here in the place where students make mistakes is they don't go from the horizontal, okay? Notice each of these angles start from the horizontal and go up to what we would call the hypotenuse, okay? So here we've got four angles. We've got angles 1, 2, 3, and 4. So this horizontal you can see is kind of like an imaginary horizontal, but it's from the top of the mountain out horizontally. Imagine somebody up here looking, out at the view, the horizontal. This creates an angle of depression because it's down from the horizontal towards this guy standing on the side of the hill. Okay, so angle 1 is an angle of depression. Angle 2, it's the view line here of this guy. He's looking horizontally out across the hill there. And so that's going to be from the horizontal up. So this is an angle of elevation. Angle 2 is an angle of elevation. If the guy's looking at this house down here in the valley, the horizontal again is still here, okay? But his viewpoint is looking down, so this would be classified as an angle of depression. And finally, if we were standing here in front of this little house here in the valley and we're looking up at this guy here on the hillside, that's going to be an angle of elevation because we're looking up. Okay, so hopefully that helps you understand the difference between angles of elevation and angles of depression. This video is going to allow us to use the angle of depression and angle of elevation concepts to set up equations to solve real-world problems. Okay, so we've got this surveyor down here looking up. We want to determine the height of the arch. Okay, so he sets up his tripod here. We've got a right triangle. We can always form a right triangle here. This base of the ground, this is directly beneath the arch, okay? And that's going to be our unknown. That's x, all right? This angle that's created by by this device here is 48 degrees, and he knows that this is a 36-foot long distance, okay? This is going to be an angle of elevation because it's from this horizontal up to something, in this case, the top of the arch. All right. Notice this 5 feet right here is not accounted for yet. We're going to have to deal with that a little bit later. Okay, so first thing we want to do is write an equation. Excuse me. We want to write an equation. So the tangent of 48 equals the opposite x over the adjacent, 36. Okay. And we solve that. We're going to multiply both sides by 36. And we get an x value here of approximately 40 feet, 39.98 feet. Okay. Now, we haven't accounted for this 5-foot difference here yet. In order to create the right triangle, this guy was a little bit, he wasn't all the way at the base of the arch. Okay. So we're going to, in order to find the height of the arch, we're going to add x and 5 there. So the total height of the arch is going to be about 44.98 feet.